Good afternoon to all. I welcome all my students in this e-learning classroom. Myself, Professor Amol Phatak, working as Assistant Professor and Head of Computer Science and Engineering Department at NVAA Sinhagarh College of Engineering, Solapur. Today, under the subject Unix operating system, we are going to learn the topic, the context of a process. In multitasking system, as so many processes are executing, the processor moves from one process to another process. So whenever it moves from one process to another process, it saves the context of a process. So we are learning today in detail what is meant by the context of a process. Let us start learning this with the help of the handwritten notes.
The context of a process consists of the contents of its user address space, the contents of the hardware register, and the kernel data structure that related to the process. In general, or in simple words, we can say the context of a process is the union of the three parts. It is the union of the user level context, register context, and the system level context. So in general, the context of a process is the combination of user level context, register context, and system level context. Let us consider these three parts in detail. The user level context consists of the process text, the set of instruction. The text of the process is nothing but the set of instruction or the program code. The second part is the data. The data of the process may be the local variable, global variable, then the user stack and the shared memory. So all this consists of the user level context. The second part is the register context. The register context of the process consists of the following points. It is having the program counter, generally we call it as a PC, which specifies the address of the next instruction the CPU will execute. Then the process status register PSR, which specifies the hardware status of the machine as it is the result of the process. So for example, maybe the result of the last computation, whether the result is 0, whether it is positive, negative, current process execution level. It also maintains the mode of operation it is executing, user mode, kernel mode, etc. The next field is the stack pointer. So it maintains the stack pointer, which contains the current address of the next entry in the kernel stack, or whether it is a user stack as per the mode of operation. Then the next field in the register context is the general purpose register. So this general purpose register contains the data which is generated by the process during its execution. This register may be A as the accumulator, B, C, D, E, F, etc. Or in some of the cases it may be register 0, register 1. The number of these register, general purpose register, and their names depends upon the machine architecture. So this register context consists of these four fields. The third and important part of any context of a process is system level context. So the system level context of a process has the two parts, the static part and the dynamic part. The process has one static part of the system level context throughout its lifetime, but can have variable number of dynamic part. Means static part is always fixed and it is with lifetime of the process, but the variable, it may have the variable number of dynamic part. Let us consider the static part of the process. Now the static part consists of process table register. Process table register defines the state of the process and the control information always accessible to the kernel. So in general, the first part, the first field, process table entry, defines the state of the process. The next is the U area of a process. The U area of a process contains the control information that is accessed only in the context of the process. So These fields may be the priority of the process, the timer fields, the login terminal which is associated with the process, etc. So the U or user area. Then the third static part is the P region, okay, known as per process region entries, the region table and the page table. Now all this defines the mapping from the virtual address to the physical address. So this P region will help us to map the process virtual address to the physical address. Though the several processes share the common region, means they are sharing the common region, then also the regions are considered as a part of the context of a process. So shared region is also considered as a part of the context of the process. So this is the static part. Let us concentrate on the dynamic part of the process. The dynamic part consists of the two fields. One is known as the kernel stack. The kernel stack is the dynamic part, which contains the stack frames as process executes in the kernel mode. Although all processes executes the identical kernel code, they have private copy of the kernel stack. So every process is having the private copy of the kernel stack as the kernel executes on behalf of the process. Okay. The kernel stack, this dynamic part kernel stack may be empty only if all the processes in the system are executing in the user mode. So if all processes executing in user mode, then only the kernel stack is empty. If any process is executing in the kernel mode, then it is not empty. The second dynamic part is the set of layers. Okay, so the set of layers on the stack, which is visualized as the last in first out. Okay, LeFO stack. Each system level context layer contains necessary information so that it will recover from the previous layer. Okay. Let us consider this in the form of the diagram. The components of the context of a process. What context of a process consists of static part and dynamic part. So we can find that it is having the user level context, having the process text, data, stack, shared data. It is also having the static part of the system level context, which is having process table entry, U area and per process region. So this consists the static portion of the context, okay, of a process. In the dynamic portion of the context, okay, this is the kernel stack. Okay, we can say this is the kernel stack, which is having the kernel stack layer 0, layer 1, layer 2, layer 3 and so on. Okay, so the layer, every layer, okay, is having the kernel stack for that particular layer. At the same time, it will save or it is stored the saved register context of the layer 0, so that, okay, when it is going to return, it should come back to the previous layer. So this indicate the dynamic portion. So this diagram indicate the context of a process in the form of static part and dynamic part. Now looking to the diagram, as per the diagram, we can say the kernel pushes a context layer. Okay, so it is going to add the context layer or one more layer, or pushes the one more layer onto the kernel stack in following cases. When an interrupt has occurred, process is executing, interrupt has occurred, it is going to push the next layer. Another case is a process makes a system call, it will move from user mode to the kernel mode, or a process does a context switch. So its execution is over or the time duration is over, context switch has occurred, so it is going to add the layer. So it is kernel is going to pushes it, and similarly the kernel is going to pops up or removes the context layer when it is going to return from it. Therefore we can say the context switch operation enables the push and the pop operation of the system level context. Okay, so as a summary, we can say the context of a process is consists of the three parts: okay, user level context, register level context, and the system level context. Okay. In the next lecture, second lecture, okay, we are going to learn how we are going to save the context of the process. What is the procedure to save the context of a process? Okay, thank you.